Hey guys, Mr. B here, and this video is just going to be going over some practice on chemical reactions and just kind of covering a lot of different things. Now this video might be sort of long, and I'm making this video because I really just want to go over all the different skills and things needed to write chemical reactions, write chemical formulas. If you're someone who needs the help and you are not one who usually watches the full length of videos, this would be one that you would want to watch everything. So I've got set up on my screen a sheet of practice. I've got our periodic table up there too. I've got mine, of course, in person, which I'll be using, but I have a visual one on the screen so that way we can use that one and look at that one as well. And we're going to be doing this on paper, okay? So here we go. So you have a sheet here that says a cycle of copper reactions. And so it says, Josie is investigating various reactions involving copper in her chemistry class. She performs each of the following reactions in the order described. Write the unbalanced chemical equation for each of the reactions. So it says reaction 1, Josie begins with copper nitrate, and they do give us a chemical formula. So this is CuNO3 2. It says she adds sodium hydroxide and a new solid is formed. All right, so she's going to be adding sodium hydroxide. So what is sodium hydroxide and how do we write this? So let me do this in another color. All right, so we have a periodic table, okay, but sodium hydroxide. So sodium is the element Na, all right? We can find that on our periodic table, which again, if we look at the one that is up here, we can see that sodium is right here. And it has a charge of +1 as an ion. Okay, so that's sodium. Then we have hydroxide. Now, hydroxide is a polyatomic ion. If we go to the back of our periodic table and we look at our polyatomic ion chart, which is this big thing here, we will find hydroxide. And hydroxide is on the bottom, on the left-hand side, right there. Okay, so hydroxide has a chemical formula of OH-. So when we put these two things together, remember that we need to do our Wonder Woman. So this 1 is going to go down on the hydroxide. This is technically a -1. This 1 is going to go down on the sodium. And when we're done, we will have Na1OH, parentheses, 1. But of course, we don't need to have 1s in chemistry, so we can just ignore the 1s. And we are simply going to have NaOH. Okay, so that is our chemical formula for sodium hydroxide. Okay, so it says that Josie begins with copper nitrate, which is shown here, and she adds sodium hydroxide, and a new solid is formed. All right, so it looks like all she's doing is adding sodium hydroxide, and she's going to have a chemical reaction, and of the products that are forming, one of them is going to be a solid. Okay, so let's first try to figure out what type of chemical reaction is happening here. Now, there are 5 main types of reactions. We have combination, which is A plus B makes AB. Okay, now when we say A plus B, typically this is going to be like an element plus an element makes a compound. Does it have to be an element plus an element? No. You could have an element plus a compound makes a bigger compound. Okay, but just in general. So like example would be maybe, for example, magnesium plus oxygen makes magnesium oxide. Okay, so we have A plus B makes AB. Combination, typically. Then we have decomposition. Decomposition is where you start with one compound and it's going to break apart into the elements that make it up. So pretty much it's going to be like the first one here, just going backwards. Okay, so this is combination. This is decomp. Okay, then we have single replacement. So single replacement is usually going to be a single element by itself, reacting with a compound, and A is going to replace B. So over here in our products, B will be by itself and A will be paired up with the element that, or the thing that was in the compound. Okay, so example of this could be like lithium reacting with hydrochloric acid. Okay, so A is lithium in this case, B is hydrogen, and C is chlorine. So then over here, hydrogen is going to be by itself, okay? And lithium, Li, is going to be paired up with chlorine, Cl. All right. We'll get into the whole chemical formula thing in a little bit here and how do we know these chemical formulas. Right now I'm just going over the different reaction types. So this is single replacement. I'm just going to write Sr. Then we have a double replacement. So that's going to be AB plus CD. And we're going to make AD and CB. Okay. Now, this is usually going to be a compound plus another compound. Remember that in these compounds, we typically have a positive ion and a negative ion bonded together. Okay, positive, negative. The positive is always going to be written first in the compound. So when these things switch, A is going to be bonding up with D because you need the positive thing to bond with the other negative thing. Okay, you can't have A bond up with C because those are both positives, and we know that similar charges don't connect with each other, right? It's like if you have two charges that are the same, right? Think of magnets, they repel. So you can't have two positives bond together, and you're not going to have two negatives bond together, right? You need a positive and a negative. You need opposites, right? Opposites attract. So A and D will bond together. Okay, so over here, again, we see A and D are together. And then C and B will bond together. And I know that C is going to be written first because, again, when we write chemical formulas, we always write the positive ion first in the formula. The negative ion is written second. So even though in here, in this, the way I've written it, it's B and then C, right? So you might think it's, oh, BC, right? Put B and C together. When they bond, C is going to be written first. B will be written second because C is the positive ion and B is the negative one. Okay, that's just the rule on how we write chemical formulas. So example of this could be like the one we actually have right up here, where copper, Cu, is A. Okay, so this is A. B is a nitrate ion. Okay, so nitrate is a polyatomic ion, which we can count as like its own thing. It's kind of like, it's not an element, but it's one group of stuff, so we can count it as like its own thing. Okay, so that's B. Plus C, okay, in this case up here, C would be sodium. So Na, that's C. And then OH is a polyatomic ion hydroxide, which just like nitrate, okay, that we can treat that as like one item of things. So we can treat that as its own thing. And that will give us, that will be our D, okay? So this is what we've got so far. And then in our product, A is going to bond with D. So A, in this case, is the copper. Okay, so Cu bonding with D. D, in this case, is the hydroxide, okay, OH. And now it is going to be like this, and I will explain again in a second here like why it is this, okay? Just bear with me here. So we have A bonding up with D. And then over here, we're going to have C bonding up with B. Okay, so C was the sodium, Na, and B is the nitrate, NO3. Okay, so these would be our products. All right, now again, I told you I was going to explain, like, how did I know that this was the chemical formula, right? Where did this come from? Okay, so looking over here, we have copper bonding with nitrate. Okay, now on the periodic table, so let's go back to we're going to look at our periodic table here, okay, to make sure that we understand. On our periodic table, copper makes two different charges, okay, +1 and +2. So this copper could be +1 or it could be +2. Now we don't know which one it is, okay? There's no way for us to just guess. But we can determine which one it is by looking at what it's bonded to. Because in this case, it's bonded to nitrate. In fact, it's bonded to two nitrate ions. So nitrate is NO3, and there are two of them. Okay, so I'm writing two of them. And if we, again, we look on our periodic table, nitrate is a polyatomic ion. So let's come back up or go to the back of our periodic table here. And we find nitrate right here. And its charge is -1. So that means that these nitrates that I have written on my sheet here each have a charge of -1. Okay, -1, -1. So total, okay, the total charge of both of these together is -2. That's our total charge. Which means that this copper, in order for this copper to bond with these nitrates, this copper has to be total of +2. Okay, so even though it could be +1 or +2, in this case, it has to be a +2. Okay, that's how we know this. So this is the charge on the copper in this compound. It's +2, which means over here, when it bonds with hydroxide, we have copper, which in this case is +2, bonding with hydroxide, which is OH. Okay, and again, if we look on the back for periodic table here, we can see that hydroxide is down here, and we had this one circled already, but there's hydroxide. It has a charge of -1. So it's OH with a charge of -1. And we had some examples shown up here. Again, when we write our chemical formulas, we need to do our Wonder Woman. We need to switch our numbers and balance them. So we are going to have this 2 from the copper go down over here, and this 1 from the hydroxide go down over there. And we're going to end up with Cu with a 1 and OH with a 2. And when we put the 2, we have to put the hydroxide in parentheses. The 2 goes outside the parentheses. Okay, and then we can just ignore the 1. We don't need to write that. And that's essentially how I get this chemical formula right here. Okay, this is the whole process on how to get that. For sodium, okay, Na, sodium is Na and has a charge of +1. Again, we saw this already when we were looking at our periodic table, but sodium again is found right here, and there's the charge right there, +1. And then hydroxide, which we just looked up, is OH, has a charge of -1. Okay, so these just go together. That's how I get this. And then over here, when the sodium bonds with nitrate, again, sodium is +1. Nitrate, NO3, has a charge of -1. Okay, we already found that. Again, it's on the back of our periodic table on our list of polyatomic ions. But it's NO3 -1. And then when those bond together, the ones switch, and then we just ignore them, and that's how we get NaNO3. Okay, so this is how we get this whole thing. This is how I got the whole thing, which, by the way, this reaction, again, is our reaction that we have here. Okay, this is our reaction. So our products here are going to be CuOH2 plus NaNO3. Okay, this is a double replacement reaction. That's the type of reaction that's happening here. And we have to determine, of course, one of these as being a solid. So it does say in the problem, a solid forms. Okay, so which one of these is going to be our solid? So to determine that, again, we'll look on our periodic table. And on the back, we have this big chart here, and this is known as a solubility chart. And we can use this to determine which one of these is a solid. Okay, so this first one, we have copper hydroxide. Technically, it's copper 2 hydroxide. Okay, it's copper 2 because the charge on the copper is +2. Okay, we determined that already. So it's copper 2 hydroxide. It could be copper 1 hydroxide, but we know it's not copper 1 hydroxide. So it's copper 2 hydroxide. So if we look on the back of our periodic table, we see copper 2. Let me do this in a different color. Okay, we see copper 2 right there. So there's copper 2. Hydroxide along the top is right there. And if we go till they intersect, we see that it says right there in that box, S for solid. So here on our reaction, we can label this one in parentheses S for solid. Okay, so we know that that's the solid that's being formed. If we go check the other one, which is sodium nitrate, okay, sodium nitrate, on the back for periodic table, again, we can find sodium right there and nitrate right here. And if we go till they intersect, it says AQ for aqueous. That means that it is dissolved in water, so it is not going to be a solid. All right? So AQ. So we label that AQ. Okay. So this is the whole reaction written out for that first problem that we were looking at, which is Josie begins with copper nitrate. She adds sodium hydroxide, and a new solid is formed. Okay, this solid is formed. We also have this as a product as well, but that's going to be just basically a liquid, so you wouldn't really be able to tell that it's there. All right, so this is our unbalanced equation. Okay, so when it says like write your unbalanced equation, that's what this is. So we can even type it on our sheet. Let's put a little text box. So you can write CuNO3 2 plus NaOH, and we get CuOH 2, it's a solid, plus NaNO3, and that is aqueous. Okay, so this is unbalanced. Now they're not asking us to balance it, so you know what, we're going to balance it anyway, okay, even though they're not asking us to, because we're probably going to have to at some point. So balancing wise, if we look here, so we have 1 copper. Okay, so you have 1 copper on the left. On the right, we have 1 copper. Okay, so those are balanced, so that's good. On the left here, we have NO3, and there's a 2. Okay, so I'm going to count this as like one group of stuff. Okay, so that's NO3, and there are 2 of them. Okay, so there's 2 NO3s. On the right, we only have 1 NO3, okay, because there's no parentheses and there's no 2 outside. So this is just going to be NO3, and there's only 1 of them. Okay, so those are not balanced, so we're going to have to balance that. So let's write a 2 in front there. Okay, that's going to multiply this. So instead of being 1, it'll now be a 2. That also now is going to give us 2 sodiums. So we have 2 NAs, okay? Here, we only have 1 Na. So this is not balanced, right? We have 1 here, and we have 2 here from that 2. So we're going to have to put a 2 there. Okay, that will give us 2 NAs. So that will balance out with these. And then this 2 is also going to multiply the OH. Okay, so this is hydroxide. Again, I'm going to count this as like a group of things. So that's OH. And there are now 2 of them because we put a 2 here, and that's going to multiply this. So there are 2 of them, okay? But if we look on the right, there actually already is 2. We have 2 OHs there already. So that is actually fine. Okay, so this is our entire balanced equation. And I know we've got like a lot of writing here, so I apologize. It looks a little bit messy. I'll box it in. Okay, so our entire finished reaction balanced with all of our products written correctly is this right there, okay? That's our equation. And again, all the work to get there, I hopefully showed accurately and detailed enough to understand. Okay, this is all the stuff that we had to do to get to that part. Okay, so that's the first part of the problem. Now the second part of the problem, or reaction 2, says Josie removes the copper-containing compound produced in reaction 1. All right, so the copper-containing compound in reaction 1 is this copper 2 hydroxide, okay, because that was the solid. So it says she removes it, and she adds it to a beaker containing sulfuric acid. Okay, so I'm going to grab a new sheet here. And our copper-containing compound that we had written, again, I'm just going to make sure that we copy everything over properly. Let's make sure this is in the right place. Okay, so we have CuOH2, and that was a solid. Okay, so this is the copper-containing compound in our first reaction that we just wrote out. So it says she takes that out of the beaker, and she adds it to a beaker containing sulfuric acid. So plus H2SO4, and they do give us the chemical formula for that, so I don't need to guess what that is, okay? Now, I'm going to assume that this is aqueous, meaning it's a liquid, Okay, most acids are liquids. They're not going to be solid. So this is what we have so far for our reactants. And now we have to predict what our products will be. So again, we have to go through like what type of reaction does this look like, right? So let me take our paper and let's just fold this down so that we can see it. Okay, so here are our reaction types. So what type of reaction does this look like? And I'll fold this part as well. So that way, again, we just have as little clutter on this piece of paper as possible and it doesn't look so crazy. Apologize, guys, for not being as prepared as I should have been. Okay, anyway, here we go. Okay, so here's our reaction types. So what type of reaction does this look like, right? Now, it could be combination. A plus B makes AB. But this whole thing as being A and this whole thing as being B is not likely. Because, again, this is usually an element plus another element. And we have a compound here and another compound. So it's not going to be combination, okay, most likely. It's definitely not decomposition because we only have one reactant usually breaking apart and we have two reactants. So it's not decomp. Single replacement, not likely either because we usually would have just an element by itself plus a compound. And again, we do not have any elements by themselves. These are both compounds. So very likely then is going to be double replacement again. Okay, where we've got element or A plus B and then C plus D and we get our products. Okay, so we're going to go, so this is A, this is B, this is C, and this is D. Okay, now again, A is copper, B is hydroxide, which is a polyatomic ion. H, that's our C in this case, that's hydrogen. SO4, okay, that is another polyatomic ion. Okay, that is called sulfate. So if we look on the back of our periodic table, again, at our list of polyatomic ions, we'll find sulfate is, let me do this back in blue. Sulfate is right down here. Okay, that is a polyatomic ion. So we can kind of treat that as like one object. Okay, that's why we can label it as D. So in double replacement, we're going to have A and C swap with each other. Okay, so we're going to have in our products over here, A bonded up with D, and then we are going to have C bonded up with B. Okay, and again, we need to rearrange our formulas. So if we look at this, okay, this is going to be copper, Cu, and it makes a charge of, again, +1 or +2. And again, I know that because if we look on our periodic table, again, if we look right here for copper, we see it has two charges. We don't know which one it's going to be. Now, technically, we kind of do know which one it is because if we look at the previous problem that we did, okay, if I flip my paper back open, this is our work from the previous one. We did determine that it is copper +2. Okay, so we do know that it's copper +2. However, in case we forgot, right, or in case we don't remember, how can we figure out again that it's copper +2? Here's how we can determine that it's copper +2. We have copper, okay, one copper, bonded with two hydroxides. So we have OH, OH. Okay, we have two of them. And the charge on hydroxide can be determined again by looking at it on the periodic table, on the back, okay, on our list of polyatomic ions right here. The charge on hydroxide is -1. So each of these is -1, -1. Total, that is a total of -2, which means that this copper, in order to bond with these two hydroxides, has to be a +2. Okay, it's got to be +2. So that's how, again, we know that it is copper +2 and not copper +1. Okay, so this is copper +2. Then, over here, we have H2SO4. So we have H, which is +1. Okay, and again, how do I know that? Well, let's go look on our periodic table. Hydrogen is found right here. Okay, and it makes a charge of +1. Now, it does say -1 on there, but all of these elements are going to make a +1 charge, okay, in column 1. The -1 is something different, so just disregard that. So you have H +1, bonded with SO4. Now, technically, there are two H's, okay, that are each plus one, but that's bonded with SO4, which is a sulfate ion. Okay, if we look on our periodic table, again, we see it on the back, sulfate, and sulfate has a charge of -2 or 2 minus. Okay, so these are our ions. We have copper +2, OH -1, H +1, and SO4 2 minus. When A, which is copper +2, bonds up with D, which in this case is sulfate, okay, SO4 2 minus. When those two bond together, we have to rebalance our formulas, or rebalance our charges to write our formula. So again, we do our Wonder Woman. This 2 is going to go down there. This 2 is going to go down here. So we're going to essentially have Cu with a 2, and then SO4 in parentheses, and the 2 goes outside the parentheses. Okay, it's going to look like this. Now, again, this is not quite correct. It's on the right track. But the last thing we have to remember is if there's a common number, okay, if there's a common number between these little subscripts that we can divide out, we have to do so. Since they're both 2's, we can divide a 2 from both of these. So this can reduce down to a 1, and this can reduce down to a 1. And we'll have Cu with a 1, SO4 with a 1. And then, of course, we don't need to write the 1's in chemistry, so you just basically ignore them. And we just get CuSO4. Okay, CuSO4. So there is our first product. Okay, and again, this is all the work to get to that formula. Then we have C bonded with B. So C, in this case, we said was hydrogen, which is H +1. And B is hydroxide, which is OH -1. So H +1 and OH -1, those would just bond together. We don't need to worry about balancing or anything because they're already balanced. So we have essentially H, OH, okay, which also, by the way, is H2O, right? That's water. But writing it as HOH is fine, okay? All right, so let's rewrite this down here with all this, junk all over the place. So we have Cu, OH, 2, solid, plus H2SO4, aqueous, and we are going to make CuSO4 plus I'm going to keep it as HOH. Okay, and I'm going to keep it as HOH just for the sake of balancing. I think it'll be a little bit easier. Okay, now we need to try to determine if one of these is going to be a solid or not. Okay, so let's look on the back for periodic table at our solubility chart. The first one we have is going to be copper 2 sulfate. Okay, this is copper 2, and SO4 is sulfate. So again, let's look on the back. Let me just erase these arrows we had from before. All right, so copper 2 is here. Sulfate is there. And if we look, we see that this is aqueous. Okay, so this is going to be aqueous. Okay, that product is aqueous, so that is not a solid. HOH, right, which is H2O. Most of you, I hope, know that H2O is a liquid, right, at room temperature. So this is going to be a liquid. Now, this is, you might think like this is bad, right? Because typically in double replacement reactions, one of these needs to be a solid. And that's not entirely true, okay? Actually, all we need is that one of these to not be aqueous. So like, as long as we have something here that's not aqueous, we're fine. And water being a liquid, okay, now it sounds weird because aqueous means it's dissolved in water, and water is a liquid. It's not aqueous, right? You can't dissolve water in itself. So the fact that water is a liquid, which is not aqueous, kind of counts as then being okay. Okay, so this is fine. So this is our whole reaction. We have to balance it. Okay. So if we look at balancing, let's take a look at our coppers first. So here we have 1 copper on the left of our reaction. We have OH. So again, I'm going to count this as a group. Okay, so we have 2 OHs. So we have 2 OHs. We've got 2 H's here. And then again, I'm going to count this as a group. We have one SO4. Okay, we have one of them. On the right, we've got one copper. Okay, so that's balanced out. So those are fine. We have one SO4. One SO4. Right there, we got one. Here we had one. Those are fine. We have one H. Okay, that's not balanced because on the left we have two and on the right we have one. And for OH, we have one OH here. Okay, one OH. And that's not balanced either because here we have two. So it looks like we need to balance this. So if we put a 2 there, that will multiply our H's. So instead of having one H, we're going to have two H's. And instead of having one OH, we're going to have two OH's because this 2 is going to multiply the OH's. So this now goes from being one OH to two OH's, which this is perfect because that then balances out our two H's here and here, and our two OH's are balanced now. And our copper and our sulfates are still fine. Okay, so our fully balanced reaction on our balanced equation is going to be this whole thing right there. Okay, that's our whole answer. That's what we're looking for part 2 of this worksheet. So let's type that in here. Okay, so our balanced equation, now it says unbalanced, but we're going to write it balanced. So we have Cu OH 2, and that was a solid, plus H2 SO4, and that was aqueous. And we're going to make Cu SO4, which is aqueous, plus we're going to write it as 2, and I'll write it as H2O, I guess, when it's in here on our worksheet, just because typically you'd write it as H2O. I just like to write it as HOH when we're balancing. This makes things a little bit easier. So, okay, so that is our whole thing for that reaction number 2. We're going to move on to reaction number 3. All right, so for reaction number 3, we have Josie adds a piece of zinc to a solution containing the copper compound produced in reaction 2. So we're going to write out this reaction. Okay, now it says she's adding a piece of zinc. So we are going to be starting with zinc. And if it's a piece of zinc, zinc is a solid metal. So it's going to be zinc solid. And she's adding it to a solution containing the copper compound produced in reaction number 2. So reaction number 2, we had this copper sulfate. This is the copper containing compound in reaction 2, which was CuSO4. This was aqueous. Okay, so this is what we have so far. We have a piece of zinc, which is a solid, being added to the copper sulfate solution, which was from reaction 2. And now, again, we have to write out our products, and we have to figure out what's going to happen. All right, so let's go look back again at the type of reactions that we can have. It's our little note sheet here from before. So what kind of reaction does this look like it's going to be? Now, in this case, again, combination. Do we have an element plus an element? No. Okay, so it's probably not going to be combination. Okay, again, this is typically element plus element. This is an element, but this is a compound. So it's probably not combination. Decomposition. Do we have one reactant, and is it going to break apart into multiple things? No. We have two reactants, so it's not going to be decomposition. Single replacement. Do we have an element by itself plus a compound? Well, we have zinc, that's an element by itself, plus this, which is a compound. So this actually looks like a single replacement reaction. Even though the last two were double replacement, this does not look like double replacement because this is an element by itself, and in double replacement, you need to have a compound plus another compound. So this is probably going to be single replacement, in which case we are going to have A reacting with BC. So in this case, A is zinc, and BC, so copper is the B, and sulfate is the C, okay? Which means then in our products, B is then going to be by itself. So B in this case would be the copper, okay? B is going to be by itself, plus A and C will be bonded together. So A is the zinc, and C is the sulfate, okay? So this is probably what our products are going to look like. All right. So just like with our double replacement reactions, I would say it's very important that we write out the ions and stuff that we're going to have. So zinc is not an ion, okay? When it's by itself, it's just a solid. So we don't need to worry about this one. But this one, okay, we have copper. In this case, it's +2. Okay, we know it's copper +2 because we determined it was copper +2 in the previous part of the reaction. And in reaction 1, we determined it's copper +2. So I think at this point, we're fine on knowing that this is copper +2. And this is reacting with sulfate, okay, a sulfate ion, which is 2-. Again, if we're not sure how to do that, we can go look at our periodic table. And on the back, we have our polyatomic ions. We have sulfate right here, which charges 2-. Okay, so we've got our Cu2+ with our SO4 2-. Over here, when copper now is by itself, okay, so again, B is copper. Okay, so when copper is by itself now, it doesn't have a charge anymore. Okay, copper only has a charge when it's bonded with something. Okay, there's charges because these need to like balance each other and bond, make an ionic bond. Okay, but when copper is now by itself, it doesn't have a charge, so it's just going to be Cu. And I don't know, I guess if you know, most people probably do, but copper is a metal. It's a solid at room temperature, just like a penny. It's made out of copper. Copper is a solid. There's no charge on it. Okay, it's not bonded to anything, so there's no charge on it. A is going to be zinc, though. And zinc, of course, when it's bonded with sulfate, is going to have a charge. Okay, now zinc is going to be positive by some number, and we'll take a look at a second, like how do we know what this number is going to be. The sulfate, though, we do know is 2-. Okay, so this is going to be SO4 2-. And as for zinc, what's the charge that the zinc is going to make? So if we look on our periodic table and we find zinc, okay, so let's go to our main periodic table here. Let's erase this stuff. Zinc is, let's put this in blue. Zinc is right here. And if we look at the box for zinc, we'll notice that zinc actually only makes one charge, and that is 2+. So we actually don't need to guess what zinc is. It actually tells us right on our periodic table, it is +2. So this is going to be zinc +2 and SO4 2-. If we know the charges, we can do our Wonder Woman. So this 2 is going to go down there, and that 2 is going to go down here like this. So we're going to have Zn with a 2 on it, okay, from this SO4. And then the SO4 in parentheses with the 2 from the zinc down and outside, okay, just like this. And again, as before, seeing as these numbers are both the same, these can both be divided by 2 and reduced down to 1. So this would reduce down to a 1. That would reduce down to a 1. So we would have Zn1 SO4 1. And then, of course, we don't need to write the 1s. So we'll just have Zn SO4 as our product. And then, of course, we can check to see if this is aqueous or not. So if we go look on the back of our periodic table and we look on our solubility chart, okay, up here, let's erase these ones that we've already written. We can check to see. So this is zinc sulfate. Okay, so zinc is here and sulfate is here. So if we see where these line up, we see that this says AQ for aqueous. All right, so that means that this compound is going to be aqueous, okay? And again, this one, the copper, I knew that this was a solid, and you should know that it's a solid primarily because if you've seen copper before, right? Copper pennies, copper pipes. When copper is just copper, right, just laying around, it's a solid. You know, we all have seen copper a million times before. So if it's not bonded with anything, it's a solid at room temperature. So that's how I know that this is a solid. Okay? It's just kind of like common sense, I guess. But either way, even if you don't label it as a solid in AQ, it's fine. Okay, the S and the AQ is really just to give more information. It's not really necessary. Okay. All right, so this is our reaction. Let's rewrite this down below, just so we don't have all this junk in the way. So let me shift this up here, sorry, so we can see this better. So zinc solid plus copper sulfate, which is aqueous, copper 2 sulfate, I guess, to be specific. And then we're going to have copper solid plus zinc sulfate, and that is aqueous. All right, And then the last thing to do for this is to balance it, right, as always. So let's start our count. We've got 1 zinc on here. We've got 1 copper. Okay, so 1 zinc, 1 Cu. This is a sulfate ion, so let's count that as a group. So there's 1 SO4. On the right, we have 1 copper, 1, oh, sorry, I should have done this way. Sorry, 1 copper. We have 1 zinc, and we have a sulfate ion, and we just have 1 of them. So actually looking at this, everything is already balanced. We don't need to do anything to it. So our final answer is this. And nothing else is needed. There we go. That's our final answer. So that was for reaction number 3. So let's type that into our sheet here. So we have ZnS, which is a solid, plus Cu SO4, which we know is aqueous, and that's from the previous reaction, reaction number 2. And we have Cu, which is a solid, plus ZnSO4, and that was aqueous. And then we don't need to do any balancing, and that's it. So, all right, so that is 3 problems right there, just kind of going over reaction type and writing products and balancing and how do we write formulas. So hopefully that helps. You know, obviously there's lots of different problems that can appear, but every one, these are kind of the steps you need to do. So hopefully that helps you. As always, though, if you want to go over other things with me, by all means, let me know, or let me know if you want a video about something, and I will make one. So, all right, guys, that's it for this one. I'm Mr. B, and I will see you later. Bye.